recording, and we are having the dog gark on our bed. Okay, no, we're gonna look at this dust here on my pants. And we're in the dark here, like there's some light over there on the other side of the room. And we're gonna kind of move the camera a little closer and shut off as much of that light as we can. Hold the camera still. And this is basically glowing in the dark, is what you're seeing. And those are primarily beta emissions, the red stuff. Green is, and blue are alpha, and it has both because there's platinum in it and palladium. And platinum has a PT-190, which is the most common radioactive isotope of platinum, and it exists in this dust of mine in large amounts. That's mostly what the dust is. And I don't think that. I know that because it moves into this stuff when I heat the metal up. It moves in and replaces aluminum. It has a very high melting point, unlike aluminum, and that's why it replaces it. I start melting the aluminum, but the metal follows the heat, and the flux that I put in the kaolinite clay, which is this white stuff here, moves it into the metal, and because it has a higher melting point, it melts the aluminum around it. It holds the heat of my flame. My flame is 1300 degrees Celsius. Aluminum melts at 650. It starts melting, and the metal moves towards the heat. Okay, and it moves, and there's a crystal structure in metal, and you can see it when you get close up to this, in the striations in the metal, and it's cubic. Platinum, palladium, gold, silver, they have cubic structure with face-centered cubic, which means they make hoppers, and platinum and palladium do that more than any other metals. The rest of them just kind of bunch up a little bit there, but platinum and palladium make hoppers, like stair steps down into the center of the crystal structure. And they're all joined together but the higher melting point stuff can move in the planes of cleavage between those cubes. Okay? And that's what happens. It starts moving into the aluminum because of the higher melting point. The aluminum just melts away from it, and it cascades. It literally draws the palladium and gold into the aluminum as the aluminum melts away out the flame. And this stuff is where it comes from. It's AuPd dust, that is basically called kaolinite clay. This is commercial kaolinite clay that I got from a company in the state of Georgia. Um, and they mine it there, or, dig it out of the ground and process it, and they use it for making plates. Plates from palladium and platinum. I didn't make it up, I just found it, y'all.